Alright, hello everyone, and welcome to Fluid Mechanics 101. So today we're going to talk about a crucial principle in fluid mechanics that applies to objects when they're submerged in water. This principle affects whether an object either floats or sinks to the bottom of the water. So that principle is called the Archimedes principle. The Archimedes principle basically states the buoyant force is equal to the weight of the displaced water. So the Archimedes principle in formulation is the buoyancy force is equal to the density of the fluid times the volume of the displaced fluid times gravity. So when you place an object into the water, the buoyancy force is equal to the fluid of the water times the volume that is displaced from the fluid being in the water times gravity. So let's say I have a bucket of water here, right? When I place an object in the water, say I place a cube, the object is affected by two forces. As we know from dynamics, it's affected by the weight force, which is equal to mass times gravity. Gravity is pulling the object towards the center of the earth. And in a fluid, it's affected by another force, which is the force of buoyancy. So, Archimedes' principle states that the force of buoyancy is equal to the density of the fluid times the volume displaced by the object. So, it's basically the volume that the object takes up. So, the water that was originally here, the object takes the space, and then the water creates more space for the object to move in. So, that is basically the volume displaced times the gravity. So, how does this principle affect whether an object will sink or float? So as we know, when the force of buoyancy is greater than the weight of the object will float. If the force of buoyancy is less than the weight of the object will sink. And if the force of buoyancy is equal to the weight, the object will stand right in the middle of the fluid. So, let's see a real world example of how this is applied.